Here we have the final frame design, hopefully, of the Magbot Model 3. The initial driving test, we had a very rigid frame, and we have since changed that, added a few pivots to increase maneuverability and to allow the robot to transition from different climbing phases. The two new pivots are here and here, and then we have a third pivot underneath the battery. What these pivots allow it to do is the actual tracks can now swivel, so it allows the robot to make movements like this, and allows the robot to make movements like that. So it's a very, very flexible frame, very strong frame, and hopefully a frame that will allow this robot to climb and make transitions from different climbing phases. So let's go demonstrate how these articulations actually apply to different climbing phases. The Magbot M3 has to transition from this face to this face and back. This can be either vertically or horizontally around a corner. The reason we have so many pivots and articulations on this robot is that the tracks, which provide the magnetic adherence to this metal surface, have to remain in contact at all times, or bad things happen. So as the robot moves forward to the edge, the pivot is right there, and the magnetic tracks will not pivot over the edge until we get that point right there to this edge. So as it pivots, watch how the frame here has to clear the inside of the tracks. So here we go over the pivot, and now you see how this frame right here has to be able to cope with these types of maneuvers. Now as the magnetic adhesion stops this front track, this rear track can then move forward, and you can see now how the pivots here, the center pivot here, and the pivot here all work together to transition over this edge. Now this back pivot is closer to the center line than the actual center of the track, so this one may have to go a little bit further. So the idea is the bottom track comes forward, and we just kind of inch our way forward until we actually get the pivot, and now we can move back. Transitioning back, same way, track comes up, and this pivot we're kind of concerned about because we may have to tension that so that when gravity will actually force these pivots from coming back like this. Don't know exactly how well that's going to work, but we're going to work on that. So this comes forward, and once it's made the adhesion, then we have a very strong base and stable base to bring the back of the robot up. Now watch the pivots again, here, here, and then down here between the tracks to see how they move to cope with this robot moving over the edge and transitioning from one climbing surface to the other. So there's the center pivot, and that is why we cannot have a rigid frame member here, because we just drag and wouldn't be able to make the turn. Now on this back track, once it gets to a point where the adhesion is low enough to where we can pull the tracks forward, we don't have to tension this back track on this maneuver, because this front track can help pull it around the corner. So there we go. That's the idea of how we're going to make transitions from to the vertical and around the corners. It's the same movement, so we just have to figure out exactly how easy that maneuver is going to be.